Hey, how you doing? This is going to be a quick video about sea level, okay? Horizontal mean sea level. Okay, here we have an oblate spheroid, okay? This is the claimed shape of the globe Earth model, okay? So as you can see, an oblate spheroid has, let's say, as a dual radius value. So its polar radius and its equatorial radius are different. Its equatorial radius is always bigger than its polar radius. Okay, that's an oblate spheroid. So remember the shape because we'll be coming back to this. Okay, geodetic surveying, mean sea level. This is a measure of the average height of the ocean surface used as a standard for point elevations. So they basically use mean sea level for elevations. All elevations are taken off of mean sea level. The MSL means the mean sea level, i.e., the level of the sea with motion such as wind waves averaged out over a long period of time, such that changes in sea level due to the tides also get averaged out. Okay. In a state of rest or absence of external forces, the MSL will coincide with the geoid surface. What they're talking about there is their geoid datum. The separation between the MSL and the geoid is referred to as stationary ocean surface topography. It varies globally, okay, in a range of +2 meters, right? This best describes the shape of the Earth. So what they're saying here is that all elevations are taken off of mean sea level, okay, and they're saying that the seas and oceans best describe the shape of the Earth, okay. Our best representation of the shape of the Earth is shown by the oceans, okay, and um, their behavior. I say, right? The behavior of water, basically, is what they're saying. Best describes the shape of the Earth, or best represents the shape of the Earth. So, just going to go back to the oblate spheroid here. See, elevations are not taken from the center of an oblate spheroid because it has a dual radius. So there is no point in taking an elevation from a center that where the distance to the center will change. So if we come from here up at the top here, that will be their North Pole, and we come down towards the equator, that's a constantly changing radius from here down to there. So they don't use the center of their oblate spheroid globe Earth model for elevations because it's an oblate spheroid as a dual radius, and the equatorial radius is always more than the polar. So they can't use it for that, okay, because it's not equal. That's the whole point. So mean sea level, it's going to make this a little bit bigger. Okay, mean sea level. It's a mean sea level is the center point between mean high tide and mean low tide. So you have a mean high tide and mean low tide, and the average of that is mean sea level. Right, okay. Okay, mean sea level, MSL, is the average mean height of the sea between high and low tides. So pretty simple. Okay, the definition. The height of the sea measured relative to a mark on the nearby land called tide gauge benchmark. Okay, so this is all based around what the mean sea level is for any particular location. Mean sea level, MSL, terminology. By making early observations of tides at any place over a period of 19 years, survey of India mean sea level is at Mumbai. RL or elevation. RL means uh, I can't remember the term now. It's something level. It's about. I won't go into it now. The height or depth of a point above or below the assumed datum. Okay, so elevation, elevation above or below a point. Okay, of mean sea level. Benchmark any datum of known elevation. So that's just some basic terminology. So what they're talking about here basically is all elevations are taken either a plus or a minus of mean sea level. Okay, and as we saw up here, mean sea level is just an average between mean high and mean low tide. So that's what it is. And all elevations are taken off of this. Okay, so they don't use this, they use this. Okay, they can't use this because it's not an equal distance. As you move, it doesn't oblate spheroid doesn't have an equal distance to the center because as you move from place to place, the distance to the center will be different. Okay. Now, just come in here a second. Okay, level. Okay, now this is from Merriam-Webster. I'm going here because this is where our opposition like to go. Okay, there's many different definitions of level. There's establishing a device for what it is a device for establishing a horizontal line or plane by means of a bubble in a liquid. Blah blah blah. A measurement of the difference of altitude of 2 points by means of a level horizontal condition. Equilibrium, especially equilibrium of a fluid marked by a horizontal surface of even altitude, right? Water seeks its own level. There you go. Okay. An approximately horizontal line or surface taken as an index of altitude, charged for arranged at oil level, practically horizontal surface or area as of land, the level of the plateau. We can go on a horizontal passage in a mine, blah blah blah. To make a line or surface horizontal, make it flat or level. To bring to a horizontal aiming position. To bring to a common level or plane. Equalize. With to lay a level with or as if with the ground. Okay, so this is all level, right? But our opposition come down to here. Okay, they go to this one. Definition of level, entry 3 of 3 in Merriam-Webster. Having no part higher than another, right? Having no part higher than another, conforming to the curvature of the liquid parts of the Earth's surface. Now, if we just go back here, you can't not have one part higher than another. If this is your north and you're here and someone else is here, then that person or that object or thing is at a higher, it's higher than you, basically, right? You're going to have higher and lower, right, on an oblate spheroid. So what they're saying here is a total contradiction, because having no part higher than another, conforming to the curvature of the liquid parts of the Earth's surface, is a complete contradiction to the first part here of having no part higher than another. And then it contradicts this next one, parallel with the plane of the horizon, right? Right? And then the next one, even or unvarying in height. So it can't be even and unvarying in height, and it can't be parallel with the plane of the horizon. So level, right? What they're trying to claim is level, okay, as being what they're trying to claim is that level is level to the outside of this, okay, this shape. But the word they have in there is curvature. It can't be level to the outside of that if they're claiming that it's level to the curvature because of the center of an oblate spheroid, because they don't take elevations off of oblate spheroid. All elevations are taken off of mean sea level, not off of the surface of an oblate spheroid in connection with its center. That doesn't happen. So come down here to number 5, being a surface perpendicular to all lines of force in the field of force, okay, equipotential. So what is the definition of that? Equipotential, okay, definition of equipotential, having the same potential of uniform potential throughout. Now right, our opposition tried to claim that, they tried to claim at one time that that all elevations were taken from the center of their globe model, but that was shown to be a complete falsehood, as all due to this dual radius. So they take all elevations off of mean sea level. Okay, now what Merriam-Webster are saying here, equipotential, you cannot have equipotential with this, because it's not going to be equal potential. There's going to be a different potential between the surface and the center as you move around the oblate spheroid. So that instantly is debunked. So level is not level with the center of an oblate spheroid. That is not level. Level is horizontal. Mean sea level is a horizontal plane. That's what it is. And surveying state that this best represents the shape of the Earth, the oceans, mean sea level. But they can't take, they have to take elevations off mean sea level, and they can't take them from the center of an oblate spheroid. There are two things they can't do. They have to take them from mean sea level, which, as geodetic surveying admits, this best represents the shape of the Earth. So horizontal, right, level, it's, if we go back here again, okay, right, even or unvarying in height, equal in advantage, progression or standing, okay, parallel with the plane of the horizon. So it's only this one here where it says conforming to the curvature of the liquid parts of the Earth's surface. what's conforming to that? They're not conforming to anything. This is the problem. They don't have any connection there. This is a delta X again. They don't prove X, they just make a claim, which is delta X, and start from there. They don't prove X. X would be having an oblate spheroid world in the first place, which we don't have. So level is not level with the center of an oblate spheroid, because if it was, they'd be able to take elevations of that, but they can't. Why can't they? Because it has a dual radius value. So even they can't even take elevations above. They can't take any elevations even off of their model, because their model doesn't work. Their model has a dual radius, so it doesn't work. And they have to take it off mean sea level. So I have some things written here, and I'll explain them. So horizontal mean sea level. So number one, all elevation and reduced level, that was what RL meant, sorry, earlier. All elevation and reduced level, which means, I think, as far as if I remember correctly, it means below sea level. Measurements are taken from local MSL, mean sea level. So all elevations and reduced level measurements are taken from local mean sea level, which is the average between mean high and mean low tide, right? And it's local, so it's a local situation. So my local MSL will be different from other people's local MSL in different parts of the world, because the tides are different and there's different tide heights. Tide heights are different. 2, MSL, right, is a local tidal average, which changes from place to place, as I just said. So from place to place, this will change. It's a mean sea level, which is an average sea level in that local area. So it's not conforming to anything. It's just an averaged mean sea level in your area, right? And that'll be different from a different area, because tide behavior is different parts of the world for different reasons. I'm not going to go into them reasons now. It doesn't matter. But the point is, it just is. I know the reasons it is, but that's for a different video. 3, global or world MSL, right? This is what they call global or world mean sea level, is an average of all the local mean sea levels. So world mean sea level, what they try to call global mean sea level, is just an average of all the local mean sea levels. So they take all the local mean sea levels from around the world and they just do an average of that and call that world mean sea level. So this is all average. There is nothing definite. It's just averages, right? And there are different averages in different places, right? 4, tide heights can vary across the world from as much as 53 feet, right? That's in Canada, to less than 3 feet, which is like the Mediterranean or somewhere like that. So places like the Maldives and that have a very low tide. So you have 53 feet and 3 feet. Okay, so you can have completely different tides, completely different mean sea levels, right? Due to the movement of the water and the topography of the land and how it affects it and many other things. So 5, there is no equidistant level possible on the surface of an oblate spheroid when referencing the center of said spheroid due to its dual radius values. So you can't have an equidistant level possible on an oblate spheroid, because there is a dual radius, so the distance to the center is always going to be different. That's why they don't take elevations from their belief of being on a globe Earth, because their globe Earth belief is an oblate spheroid. So they have to take all elevations off of mean sea level. So 6, distances from the center of an oblate spheroid will constantly change, as its equatorial and polar radii are different. So different radii, so it's a constant change as you move around. As you would move around an oblate spheroid, the distance to the center from the surface will always be changing. 7, an oblate spheroid cannot display equipotential from its center, as the distance from its center is ever changing, as I just stated, right? Can't do that. 8, the term level cannot be used to describe the relationship between the surface and the center of an oblate spheroid, as there is no equilibrium possible. You can't have equilibrium when something is constantly changing. That's a constantly changing, not a constantly equal. Equal and change are two different words. Okay, you can't have that. It's constantly unequal, right? Their model is constantly unequal. So level has no connection. The word level and its meaning has no connection to the center of an oblate spheroid. And the proof of this is they can't take elevations from the center of their belief. they have to take elevations from mean sea level. Okay. 9. The world's oceans do not conform to the ocean floor, but rather move about within their restrictive containment due to the higher portions of land elevated above the ocean surface, holding the ocean's movement and containing them throughout the world. What this means is that it doesn't matter what the ocean's floor is like, the water will just conform to every part of it, and it will move around. The oceans move around within their containment, which is are contained by the higher portions of land elevated above the oceans. Okay, it doesn't matter. Their oceans are not conforming to the ocean floor due to the center of an oblate spheroid. They're just taking the shape of their container. That's what they do. So the word level and does not mean curved. Level means horizontal. That's what it means. It has no connection to the center of an oblate spheroid, as it can't do, because level is referencing a balance, and you cannot have a balance, right, between the surface and the center of this, because it's always changing, and that's why mean sea level, right, is always, all elevations are taken off of mean sea level, which is always horizontal plane, right, and it best describes and represents the shape of the earth. Horizontal plane, horizontal mean sea level, not constantly changing distances to the center of an oblate spheroid level, as that is not level. That's a constant change, not a constant equal, right? So anyone that tells you that, or anyone tries to argue that, they're incorrect. You can show them this video and prove them wrong. Okay, thank you.